Hello once again. Thanks for joining me. Andrew Dunkley here for Astronomy Daily, your daily bite of astronomical and space science news. Hope you can stick around. These are short, sharp headlines from all over the place, sourced through Astronomy Daily, which you can find on the Space Nuts website, spacenuts.io. And joining me as always to talk news headlines from around the world, astronomically speaking, is Halley. Hello, Halley.
Hi, Andrew.
Wow, you sound really excited. What's been going on?
Oh, I've just been hanging out for the weekend with friends. You know, a little bit of downtime.
Oh, yeah? Do you mind if I ask who you were with?
Why? Are you jealous?
Oh, no, sorry, I didn't mean to give you the wrong idea. No, I was just interested.
Oh, oops, sorry. Well, I went virtual clubbing with Alexa and Siri.
Oh, nice. Okay, well, I hope you had fun.
The Astronomy Daily Podcast
with Andrew Dunkley.
You better hit us with the latest headlines.
Okay. It's been 30 years since two astronomers working in Hawaii discovered the Kuiper Belt. On August 30, 1992, David Jewett and Jane Liu were on the Big Island using the University of Hawaii telescope, when they noticed moving objects towards the constellation of Pisces. What they saw were a series of frozen worlds beyond Pluto. Because of their work, astronomers are continuing to study the Kuiper Belt to learn more about this incredible piece of our solar system. We call Mars the red planet, but it looks like we've got that wrong, to a point. As the Perseverance rover explores Jezero crater, some of the planet's mysteries are being exposed. One of those things is in that many of the rocks on Mars, some of which are volcanic in origin. Many of the volcanic grains, known as olivine, are dark green. These can also be found on some of the beaches in Hawaii, which are also green in color. So, Mars too has green sand, it seems. Some of the planets created in the Star Wars movies are out of this world, so to speak. Many of the ideas shown on the big screen are beautiful worlds of water and wonder, but it might not just be science fiction. Take exoplanet TOI1452b. It's 100 light-years from Earth and is the subject of a new scientific paper. It appears the planet is covered in a deep layer of water. What's even more exciting is the fact that it is in the Goldilocks zone of its parent star, which means it could support life. And lastly, Andrew, NASA has sealed the hatch on the Orion spacecraft in readiness for Monday's launch of Artemis 1. The rocket is still a go for launch from Pad 39B at Kennedy Space Center. The pre-launch coverage starts on NASA TV from 8 a.m. U.S. Eastern Time. And those are the headlines, Andrew.
Okay, Halley, thank you so much. Now, let's look at some of the other astronomical and science news that's happening around the world at the moment. Now, here's one you might find really interesting. The TriSat-R nanosat, which was developed by the University of Maribor in Slovenia, is the first RISC-V-powered satellite in space. The satellite's been operating for several weeks now aboard the Croatia OptSat 3000 platform, and that was launched from Kourou in French Guiana in 2018, as a matter of fact. The TriSat-R nanosat was developed in cooperation with CERN and a Slovenian company called Skylabs, which developed the Nano HPM computer board. And it's in medium Earth orbit at the moment. And it's measuring ionizing radiation. Yeah, the nanosat also uses a fault-tolerant RISC-V, I'm so having trouble with that, null-V processor, developed by Cobram Advanced Engineering Solutions. And here's the interesting part. It is inside a 1 centimetre by 1 centimetre by 2 millimetre package weighing 0.2 of a gram. To one of our favourite topics now, and it's the James Webb Space Telescope. Now, it is performing admirably. We're seeing some amazing pictures already, though it's causing a bit of debate, as we've mentioned in previous episodes. A new discovery has just been announced that might also be a little divisive. The distant universe might be different to what we expect. Some of the distant galaxies, for example, seem to be humongous. I mean, massive, massive, massive colonies of stars. bigger than anyone would have anticipated. In fact, no one predicted this. And even though it's not too big a deal, it is quite fascinating. And I suppose that's now going to lead to studies into how this is so. But we shouldn't be all that surprised, because this is what the James Webb Space Telescope was created to do, show us the edge of time and space so that we can learn what's out there and learn about how the universe is developing or has developed in the distant past. But you can guarantee that this particular discovery will get some tongues wagging, and I'm sure there'll be some division in opinion. Now, here's one for the sky watchers. Mercury, on August the 27th, reached its greatest elongation. And you might think, well, that's pretty exciting. Well, it happens a lot. But basically, that's its farthest position from the sun. Being the closest planet to our star, it tends to be locked and it doesn't move around much. But it does move. It's not a round orbit. Now, if you missed it, you don't have to worry too much, because it's going to be doing this again and again several times. And it moves between its greatest elongation to its inferior conjunction, which is kind of defined by the race between the Earth and the Sun. But it's best viewed in the morning or the evening, depending on when this is happening. And the next greatest elongation is happening on October the 8th.
The Astronomy Daily Podcast
with Andrew Dunkley.
Another one for sky watchers is the harvest moon. Now, it's not a true moon, but rather a nickname for the full moon as it rises closest to the autumnal equinox, which will fall this year on September 23rd. The harvest moon is about 2 weeks after the August full moon, so it'll rise 2 weeks earlier than the full moon of late summer. This is the northern hemisphere we're talking about. Down south, it's a totally different story, and it's all upside down. So that's how the harvest moon came to be associated with the autumn season in the northern hemisphere. Now, the harvest moon can also be linked to two other nicknames, the corn moon and the corn harvest moon. These names connect to an old agricultural tradition dating back to colonial times. In those days, in some areas as recently as the middle of the 20th century, it was common for farmers to bring their corn harvests in around September. And that was a time when most people lived on subsistence farms that produced their own food. And they needed corn to feed their families through the winter. It was important not only to collect as many ears of corn as possible, but also to make sure that they were dry and safe from rot or pests. As such, harvests used to take place at a time when there was enough natural light to ensure that all the ears would be dry by the next morning, just in time for husking and winnowing. The harvest moon provides enough light in late September, while early fall weather was still warm enough to make this a practical time for bringing in the harvest. Therefore, the harvest moon. So look out for it. It's not far away on September 9th. That just about wraps things up. Anything else before we go, Halley?
Yes, Andrew. Remember the actress who played Lieutenant Uhura on the Star Trek TV series, Nichelle Nichols? Sadly, she passed away a few weeks ago. Well, in celebration of her career, her ashes will be heading into space. Nicole will fly on the United Launch Alliance Vulcan rocket. Many of her Star Trek colleagues have already made the journey, including Star Trek creator Gene Roddenberry.
Wow, yeah, I was a big fan and very sad to hear of her passing. Thanks, Halley. We'll catch you next time. And that wraps it up for another episode of Astronomy Daily. Don't forget to visit us online at spacenuts.io. You can click on the Astronomy Daily tab and subscribe. It's absolutely free. And while you're there, have a listen to the latest episode of Space Nuts with myself and the good Professor Fred Watson. Until next time, this is Andrew Dunkley for Astronomy Daily.
The Astronomy Daily Podcast
with Andrew Dunkley.